Hello everybody, welcome back. Today we're only 6.8, the midpoint of a line segment. Again, this is not in your textbook. This is just some additional questions that we're going to look at. There's no textbook questions, there's just a few practice questions at the end. So 6.8, the midpoint of a line segment. We're going to determine the midpoint of a line segment. This is the formula we have here. We take the average of the x values and the average of the y values. Very straightforward, and that's going to be the midpoint. If you look at your example, you can obviously tell that the midpoint is 4 and 3 here. You go down 2, right 3, down 2, right 3 again. So the midpoint here is at M. So that's what we're going to be calculating here. So the coordinates of M are going to be equal to that. So what we'll do is we'll plug in our formulas, all right, and we will calculate those. So it doesn't matter which one you pick first. Like I said, I usually use the values, the point to the farthest left, okay? So that's how I calculate it. So we're going to say that's equal to, actually I'll put it underneath here, is equal to, so the midpoint of AB is equal to, and then we just plug our values in. So x1 we'll have is 1, x2 is obviously 7, all right, y1 it would be 5, y2 would be 1, all right, so the midpoint of AB is equal to 8 divided by 2 and 6 divided by 2. So the midpoint of AB is equal to 8 divided by 2 is 4, 6 divided by 2 is 3, and it was 0.4 and 3 as we mentioned right here, 4 and 3. Okay, so that's how you find the midpoint. All right, so the midpoint AB is equal to, when you use that formula, so that's the midpoint formula. Okay, pretty straightforward. There's a check your understanding question there as well. We lost our graph, so I'll bring that back up. All right, apologies. Oh, take that down after the question, obviously, and then we'll look at example 2. All right. Again, if they're perfectly, some of these points are perfect like this one, you can tell it's 3 and 4. You go, just by looking at the slope. Slope is up 6, right 2, so it's 3, so it's up 3, right 1, and you can see that the point is clearly 3 and 4, right? So that's the midpoint. All right. But a good formula to use here is like a question like this when you don't have a graph and you just have the points. Since an engineer has to design a highway, so that is the same distance from Port Whitby, located at point 3,826, 2014, and Comet, located at C, 6,792, and 1996, 1,996. Determine the coordinates of one point on the highway. So we'll find the midpoint. So I've written my formula, midpoint of PC, or sometimes they'll just call it big M, right? Sometimes you'll just see it as big M for midpoint. I don't like that because you might get confused with slope, so I just say midpoint of PC. It does not make any difference. So midpoint PC. So the x values, just take the two x values, add them together, and divide them by 2. So it's essentially you're taking the average, right? Which makes sense, right? Because you want to get in the middle. All right? 6792, and then 2014. Sounds like the year. That's how I'm saying it, but 2014, 1996. Okay, so we'll plug them in. Now we add the numerators, right? So when we add those numbers together, I'm just going to run the calculator so I don't mess them up here. 26 plus 6792. That would be 13,618, and then we divide it by 2. And then 214 plus 996, that would be 40, oh, wrong spot, sorry, 4,010, okay, and midpoint to C is equal to, and you get 6,809, oh, not 60, 6,809, okay. And that would be 2005. Okay. Oh, 2005. And that's it. Just add numbers together and you're good to go. Okay. So that would be 1 point. It's the midpoint. It said to determine the coordinates of 1 point on the highway. So that's just the way I did it using the midpoint. It's not only 1 point on the highway, it's directly in the middle. And I think that's probably what they've done in the next question. Looking at it quickly, they did the same idea. Okay? So to check your understanding question, you guys can try that. And there's the answer right there on your sheets. So determine the endpoint of a line segment. Given other endpoints. So you can do this graphically, or you can do it with a formula. So I'm going to show you both ways. I'll do the formula and then I'll do the graph. Okay? Do it both ways just to get the handle on that. Okay? So in this particular question, it's a little different. I've broken the formula up into 2 different parts. So the x value is going to equal to the average of the x's divided by 2, right? So this is your midpoint x value, and these are your endpoint x values. This is your midpoint y value and endpoint x value. So if j is your endpoint value, then you can plug that in for x1 and solve for x2, or vice versa. It doesn't matter which one you pick. I'll put it in for x2. So I'll put plus a negative 3. Just be consistent with both. Okay? And then it says point M, the M midpoint. So remember, this x value is your midpoint value. That's going to be equal to 2. And then you would just solve for x1. Do the corresponding same thing with y. Remember, this y value is your endpoint. Now, if you put this one in as x2, this one here has to also be y2. So the 4 goes right here. And then your y value, your midpoint, is 1, and there you are. And then you just solve. It's very straightforward, right? So in this question here, obviously what we're going to do is we're going to multiply both sides by 2, all right? So by multiplying both sides by 2, that's gone. The denominator's gone, and multiply that by 2, and there you are. So then we get the endpoint being 2 times 2 is 4. And then we add the 3 to both sides, and we get 7. So the other x value of the endpoint is 7. Okay? Do the same thing here. So this is going to give us, we multiply the both sides by 2. So we get 2, obviously, oh, that disappeared on me, sorry. We're going to have the 2 times the 1. Yeah, so a little mistake there. 2 times the 1, so that would give us obviously 2 plus 4. And then we subtract the 2 from both sides, and we get negative 2. So the end coordinate of k is 7 and negative 2. So we can do that using Desmos, so we'll bring that up now. All right, we'll put those in. And so I have my j point. All right, I'll take that k point for now. So I take my j point, it was at negative 3 and 4. And then my midpoint was at 2 and 1. So I know that my point k needs to be somewhere down here, right? And how do I get that? Is I just look at slope. I went down 3, right 5. So I go down 3, right 5 again. And that'll take me to k, which has the coordinates 7 and negative 2. Which gives us the exact same as our previous graph. So we can put a line through that if we want. And I can do that now. So I did that. I'll get rid of my graph, and I'll take the one we worked on in Desmos together. There it is. Do a straight line. Again, just confirmation that we got it right. It's hard to get around. We use the formula. I showed it with rise and run, and put a straight line through, and clearly going through all the points. Just check your understanding question there as well. You can work on that. There's the answer. It's going to be 7 and 1, negative 1. There's a graph as well for that. That's it for 6.8. Just a couple of practice questions. 3 example questions. There's some practice questions as well. 2 practice questions, and there's your answers at the bottom. In the next video, we'll look at 6.8, equations of lines of best fit and correlation coefficient in 6.10. All right, thanks everybody for watching, and we'll talk again soon.